Thanks for joining me. Today we're going to be going through some periodic table things. Today is periodic table, looking at metals, nonmetals, and metalloids. And kind of what we're looking to do is to understand how groups of elements on the periodic table share some of their similar properties. And hopefully by the end of this, just by looking at the periodic table, you might be able to infer some characteristics of an element, even if you have no idea what it is, just based on its location. So our new learning content and objectives are going to be just answering the question, what are physical and chemical properties? Again, that might be a new term for you, for us to think about. A couple of other things we want to be able to do is look about how the periodic table is organized into similar substances. Lots of vocabulary with this, and so I want to remind you that you need to stop the video and write these things down. You need to rewind the video and write these things down. This video is hopefully helpful, but it's going to be even more helpful if you're taking adequate notes. And so the upside of this video is you can stop, make sure that you've got these terms down so that you kind of know what to study and what to look over. All right, so let's move on. To use this term properties, usually we can talk about things in terms of their physical properties or chemical properties. So when we start off with physical properties, first of all, properties are just a description of the matter that we have. And so a physical property is one type of description. If we're given a physical property, it's largely just a descriptor that we can use without turning it into something new. And that may seem common sense, but when we contrast it with chemical properties, it's a little bit different. So physical property, things like, how much of it do we have? How dense is it? How heavy is it for its size? What color is it? Does it have a certain smell? Does it shine? These are just descriptions we can make about an element, or substance, or anything without having to see, does it turn into something different if we place it with another chemical? So we got a bunch of examples shown in this image. Some of these are more relatable to chemistry, some of them maybe not quite so much. But again, we could measure all these things about an object or a substance and describe it, and we're just kind of sharing its physical characteristics. What does it look like, and so forth. There's some special terms that we'll use for this unit, and again, these are ones where you want to pause and write this down on the next slide. Malleable, ductile, brittle, and things like conductivity. So what do those words mean? Malleable means it can be hammered into thin sheets. So if we look at the picture up here at the top, it looks like something like gold. You're probably familiar with aluminum foil being something similar. Ductile means is we can pull it into wires, such as this copper that's here. That would be a physical property. Some things are brittle, so they break easily. The picture up here at the top, if it's malleable, it's probably not brittle. We can make it into a sheet. We probably won't be able to break it. Some things are conductive. In other words, electricity will move easily through it. The opposite of that would be an insulator, and insulators don't have electricity move through it very well. So again, if you need to pause the video to write these down, I encourage you to do so. In addition to physical properties, we have chemical properties, and these are a little bit different because chemical properties, we can't really describe them unless we try or possibly change the substance into something new. In other words, will it burn? Will it rust? Will it corrode? And so there's a number of examples that we have up in the box. Oftentimes we have to define kind of what's going on with them. So some of the examples, if I put it in water, what will happen to it? Will it react with water? Will it react with oxygen? And so when that happens, one substance ends up turning into a different substance, and we can't really go back from where we started. Now, how does this relate to the periodic table? If we look at all the elements on the periodic table, this one's color-coded into 3 different groups called metals, metalloids, and nonmetals. These are not technically groups because usually a group is an up and down column on the periodic table. But if you look at this image, you can see that they're kind of chunked again. So that we see patterns emerging on the periodic table again. They're not randomly scattered all over the place. Generally, elements are like their neighbors to some degree in terms of their characteristics. So you saw most of the periodic table ended up being metals. That's all this blue part that's down here. They make up most of the periodic table. Right? And they have certain characteristics to them. They tend to be shiny. They tend to be malleable. There's that word again. They tend to be ductile. They tend to be conductive. And another thing in terms of chemicals, they tend to react with acids. So if you put hydrochloric acid on any of these metals, you would tend to get a new chemical out of it. You may have seen something similar like this if you left spaghetti sauce, which has a lot of vinegar or acidic in it or acid in it. If you leave it on aluminum foil, it may over time react. Some aluminum foil may look like it's going to disappear. So those are some properties of metals that we have on the periodic table. Again, you might want to stop to write these down. Most of them are also solids. There's one exception, which is mercury. We used to put those in thermometers. But we don't do that anymore. If we move to the other side of the periodic table, these are what makes up most of the right-hand side of the periodic table. You'll notice there is one exception to that, and that would be hydrogen. Hydrogen is a gas. Hydrogen is definitely a nonmetal, but it's placed in this first group because of what we've talked about before, which is the number of valence electrons. Hydrogen's outside shell of electrons is similar to everything that's in that first group, which is why it ends up being over there. I've seen some periodic tables where it's actually over beside helium. Um, Nonmetals are the opposite of metals, basically. There are some that are solids, but by and large, they're gases and liquids. They tend to be brittle. They're non-everything else. So they're non-malleable, they're non-ductile, they're generally non-conductive. All the things that metals do, non-metals don't, hence the name non-metal. They will react with a metal, though, and that means a metal would also react with a non-metal, and we'll spend a lot of time in the coming unit talking about metals and non-metals reacting. In between, there's this little sliver of things in the pink. These are called metalloids. These are kind of the ones that are in between. They're between a metal and a non-metal. And in terms of characteristics, what that ends up looking like is they have characteristics kind of both or neither. They're not very well defined in terms of falling into a category. If you look at the picture, they tend to, if you see them, they're shiny, right? Most of these things, if you looked at them, you might think they're metals, but they don't conduct electricity very well. Some of them are a little bit brittle, even though they're metals. You couldn't hammer these into sheets. And so they're kind of the dividing line, the fence, if you will, between the metals and the non-metals. One of the questions I've had recently when people have looked at the periodic table is asked, what is this line? What is this bold line that just shows up on the periodic table? This bold line is our dividing line, basically between the metals and the non-metals. Effectively, every element that's touching or actually bordering that line tends to be considered metalloids. There's debate between chemists and different people about which ones are metalloids and which ones aren't, because it's not a nice, neat thing. Typically, people don't believe, most people don't associate aluminum or carbon with being metalloids. Most people would think aluminum's a metal because it's aluminum can, carbon's a non-metal, but all these other ones that are green are typically associated with and classified as metalloids. So in summary, we can look at the periodic table of having three large sections. Over on the far left, we've got the metals. That takes up the majority of the periodic table. Eventually, those metallic characteristics change and start giving way to what are the slight number of metalloids. And then eventually, that's going to turn into what we classify as the nonmetals. So there's some other things that change as we move from one side to the other. Again, they go from shiny and hard to tend to be things like gases and liquids that don't conduct electricity. And one of the things we want to remember is that typically these elements are going to share properties with things in their area. So particularly the things up and down above them, but also to some degree the things to the left and right, particularly the metals that are kind of in the middle of the periodic table that we have there. All right, hope that was good. Thank you for watching.